Hi students, today we're going to be addressing the epidemiologic triangle, which is also sometimes called the epidemiological triangle. This should accompany our discussion of cholera, influenza, and COVID-19, and should give you some tools for thinking about how infectious disease epidemics begin, and potential dynamics for their disruption. So the epidemiologic triangle is essentially the simplest ecological model that you can find, yet it's really useful. It has three vertices. Those are the 3 points of the triangle that bring together the agent or the disease-causing organism, the host or the organism that's infected by the agent, and the environment in which these come together. They all also are modeled across time because different aspects of time can impact the opportunities for infection and also the opportunities to interrupt transmission. So the agent is simply the microbe that causes the disease. We can think of it as being the what of the triangle. For example, is it a virus? Is it a bacterium? Is it fungal? More specifically, we can refer to the agent by its scientific name. So we might be talking about Vibrio cholerae, or influenza virus A, or SARS-CoV-2. The characteristics of different pathogens are going to impact the risk of disease transmission in the course of that disease. So if that pathogen can survive for an extended time outside of a living host, that has an impact. If they're able to reproduce outside of a host, that has an impact, and so forth. The host is the organism that harbors the disease. That means it's the who of the triangle. This includes both organisms that get sick and who have symptoms, in some cases can potentially die from the disease, and then others that may be asymptomatic carriers. And that can be an individual or a species level trait. So for example, when we've been talking about zoonotic transmission, we've addressed how you can have reservoir hosts in which a pathogen can circulate within the population while causing relatively few impacts on the host. And then you have hosts that get sick with the virus. And who do have symptoms and who can also be sources of continued spread, but who are themselves affected. So different individuals of the same species also who are exposed may have different susceptibility to the pathogen and may mount different immune responses, in some cases behavioral responses to the pathogen upon infection. And then there's the environment. So the environment is going to address the external factors that allow for disease transmission, or that's the where of the triangle. It includes different features of the surroundings that are going to make it more or less likely for the agent to come in contact with the host and to thrive in that setting. So if it's a pathogen that thrives in dirty water, then the quality of the water in the area or the sanitation system has an impact on the environmental opportunities for that agent to come in contact with hosts. Some pathogens behave differently or reproduce better at different temperatures, and that also makes it part of the environment. Environmental conditions that are features in some ways of the built environment that can allow for more crowding or for separation of people, that have an impact on the ventilation for indoor facilities and so forth, all can make it more or less likely for the agent to come in contact with the host. And again, time is also a factor in bringing these three together in terms of how frequently or for how long the interaction occurs between the host and the environment, for what amount of time an infected host can pass the agent on to another individual, and the time that is involved to make the necessary interventions to interrupt transmission from a public health perspective. So what you should know is that the mission of the epidemiologist is to break at least one of the sides of the triangle, disrupting the connection between the environment, the host, and the agent, and stopping the continuation of disease. I'd like for you to use this model in thinking through the infectious diseases that we're talking about this semester, and to use it as a way to kind of visualize and think through how hosts and agents come together within certain environments and what can happen, what can be done through global health measures to interrupt any of those sides of the triangle. Thank you very much.